Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Irfan bin Khairi Asli, and I'm going to explain about our project. Our project is task 3, which is design and analysis of swinging a mesh on a string. And what we need to do for our project, which is we need to do a few swinging motion on a different mesh using different type of string and length. And after that, we need to do analysis on the experiment by using the concept of centripetal force, known as uniform circular motion. And we need to do the project according to these photos. As you can see, we need to swing an object horizontally, and you can see here the centripetal force acting on the string, and reaction force and the movement of our object, as in this picture. It's travel in circular motion horizontally. Okay, and what is centripetal force? Centripetal force is the force that allow the object to move in a circular path, as shown in the photos in the picture. And I want to show you the simulation of our project, the movement of our project. And okay, you can see that we need to move the object in a circular motion. And I proceed with calculation, and the first design mechanism rope with mass 0.1 kilogram, and we assume the mass, the velocity is constant at 7 meter per second, and the string, the rope is 1 meter length. And we know that the force centripetal equal to mass times acceleration, which is v velocity power of 2 over radius. And we calculate, and we got 4.9 Newton. And for the neck is the length of the rope with 1.5 meter. And in this situation, the speed is not fast enough to make the ball move in circular motion horizontally, full horizontally, which is there is no theta here. There is no theta over here. So in this situation, we need to consider this, because there is theta here. We need to consider the weight of the object itself. So there is we need to determine the FCY and FCX. So we know that FCX is equal to FC, which is here, mass time acceleration. So, and FCY equal to mass time gravity, which is the weight of the object, the weight of the object here. So the calculation we need to find is the resultant force to get the FC. So FCX we got 3.7 Newton, and FCY we got 0.981 Newton, and the resultant force FC, force centripetal, is 3.41 Newton. And it is the same situation as this. Okay, with the length of rope with 2 meter, and here we got the calculation. FCX equal to 2.4 Newton, and FCY equal to 0.981 0.981 Newton, and resultant force we got 2.63 Newton. Okay, that's all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azimi bin Muhammad Yasin. So today I would like to present about our project, which is design and analysis of swinging a mass on a string. So the objective for this project is first to study uniform circular motion, and second is to determine the relationship between centripetal force Fc and the period t of the rotational motion. So this is our kinetic diagram, and for calculation, this is the calculation for straight wheel mass with mass 0.3 gram, and the velocity is constant 7 milli per second. So the formula for Fc is mass multiplied by velocity square root 2 and divided by the radius, which is the length. So first we calculate for the length straight with 1 meter. So this is the formula. So Fc equal 0.3 gram multiplied by 7 milli per second square root and divide 1 meter. So we get 14.7 Newton. So this is length calculation for length of straight with 1.5 meter. So same 0.3 gram multiplied by 7 milli per second square root and divide 1.5 meter, so we get 9.8 Newton. This is for FCS. So we need to find for FCY mg. So 0.1 multiplied by g is gravity 9.81. So we get 0.981. So for the FC, we use another formula, which is FCX square root plus FCY square root. So we get 9.85 Newton. Same with the length rate with 2 meter. Same calculation. So for FF we get 7.35 Newton, and FCY is 0.981. So FC we get 7.42 Newton. So this is a position of the mass the swinging is stopped. 1 meter we get 0.75 meter. 1.5 meter, distance is 0.90 meter, and for the 2 meter we get 1.15 meter. So the position of the mass the swinging is stopped absolutely is for the 1 meter we get distance 0.45 meter, and for length 1.5 meter, distance is 0.62 meter, and for length 2 meter, distance is 0.73 meter.
Okay, my name is Anas Hushaidi bin Kamal Zaman. I would like to present my part for calculation. Okay, for this part, uh, we are using a treat with mass 0.1 kilogram and constant velocity, which is 7 millimeter, 7 meter per second. Okay. Uh, for the first part, uh, that's okay. For this part, it's using a thread with 1 meter length. So if you can see in this diagram, the string was rotating horizontal, which is 90 degree. So the centimeter are perpendicular the human body. So for this part, we just need to use the centripetal formula and it will get the answer. Okay, for the next part, which is length of thread is 1.5 meter. Uh, we expect that we expect a change in angle of the rotation of mass, but uh, we don't know the angle, the value of the next. We find this formula, which is y. After that, it will gain the answer. It's same for the next question. It's same like the above question, but we just only need to change the the length of the thread, and then by using the same formula, it will we will gain the answer.